and kind of do what I call leveling the playing field. Some of you have had chemistry in the past, some of you have not, and so I like to take time to make sure that everybody is on the same page. So with that being said, you're going to want to get your notes and your notebook and paper or something to write with, and here we go. So what we're going to do is we're going to take a moment and talk about different types of matter. So we've talked about materials and what makes our materials. And so to understand how our materials become what they are, we kind of need to look at it at the atomic level. So we're going to kind of focus on the types of matter. So we have elements and compounds and mixtures. So what makes each one what they are? Well, an element is one kind of atom. It's the basic building blocks, and they are found on the periodic table, and they make up everything. So if you really stop to think about it, there's over 100 elements that have been discovered so far. That means that everything you see, touch, feel is made up of just those elements, nothing else. So now when you look at your periodic table, and you will actually get a periodic table to use, is they're going to be represented by symbols. So for example, here, this is my symbol for gold. And well, you'd be able to see here in a second, the symbol for sulfur and zinc. And so when you look at your periodic table, you'll notice you'll see the symbols, and this is kind of what they all, stand for. We also have compounds. Well, compounds are going to be two or more elements that are chemically combined. Their properties are different than the elements that make them up. And these compounds and these elements are put together in such a way that the ratios are not, they're definite for that compound. If you change that ratio, change the number of one element or the other, you now have a completely different compound. So for example, salt, down at the bottom, NaCl. Sodium in and of itself is pretty much extremely reactive with moisture. And chlorine is a poisonous gas. But once you take those two elements and you put it together, you actually create table salt, which is something we eat and enjoy daily. So think about it, we're taking two things that are hazardous and or deadly, but once combined, they're stable, they're safe to be eaten. The next one we have are going to be mixtures. Mixtures are going to be two or more substances physically combined. So compounds are chemically, mixtures are physically. And what that means is that since it's physically combined, we can take it apart. And each component does maintain their own properties. Even though they're mixed, they still behave as they did when they weren't. So the ratio from which they are mixed are going to be all over the place. There's no formula for these. And some examples would be things like Kool-Aid, Jell-O, salt water. And so mixtures you can take apart easily, and a compound cannot. It takes a lot of energy and a lot of science to actually take those apart. So what I'm going to have you do is there is an activity that I'm going to have you complete, where I call it the nuts, bolts, and washers activity. So what you're going to have is you're going to have some pictures of literally nuts, bolts, and washers. And you're going to have to identify if you are looking at an element, if you're looking at a compound, or if you're looking at a mixture. So an example would be if you see a picture where everything in there is just a bunch of bolts, I would consider that an element. So that bolt is representing an element. Now, if you happen to have a bolt with a washer on it, that would be considered two elements put together, and now we have a compound. A mixture is going to be when you have a little bit of this and a little bit of that. So you may have a few nuts, you may have some bolts, you may have some bolts with washers. And the idea is I'm going to want you to think about it and think, do you have a mixture? And is that mixture of elements? So you have one bolt, one nut, one washer, and they're all separated. That would be a mixture of elements. Or are they actually connected with each other? And then that would then become a mixture of compounds. So with this, this is my chance to get to see what do you know and what do we not know. Some of you are going to find this very easy and some of you might find this challenging. And that's going to let me know who are my chem kids and who are not my chem kids. So good luck.